2034, stock price fluctuation. So you're given a stream of records about a particular stock. Each record contains a timestamp and the corresponding price of the stock at that timestamp. Your objective is to implement the stock price class. A couple methods that come with this class are current, maximum, and minimum, which returns the latest, the maximum, and the minimum price upon called on. And if this was all the problem was, this would be a very straightforward problem, as we could just store the maximum and the minimum in a variable and continuously update that whenever we get a higher or lower value. And that would be pretty straightforward. However, this problem is not that straightforward, as there are two constraints that are introduced. The records do not come in order, and some records may be incorrect. So this part is important, as some records may not be right in terms of we could get a timestamp of 3 with a stock price of 15, and this could be the maximum price with, say, we introduced a whole bunch of other values that were less than 15. Then we could get a timestamp later on in the stream of, so say we got some more values here, we could get a timestamp later on the stream of 3 with, say, a value of 5. Now, our maximum price, therefore, was actually incorrect. So we would have to find a way to update this maximum price. And the way to do that is not to store it in one variable. We're going to need some other type of data structure where we can easily get rid of this 15 and go on to whatever the next value is. And the easiest way to do that, I believe, is to use a max heap and a min heap for the maximum and minimum. And the way to do this, and the trick here, is every time we update the price, what we're actually going to update is we're going to update a hash map. And we are going to store the timestamp and the price in this hash map. And the confusing thing for me originally was not realizing that for the heap, whenever we updated it, whenever we called update, we actually don't need to update the heap. We only need to update the heap when we call maximum and minimum. And the only updating for the heap that we need to do is we need to ensure that whatever we pop from the top of the heap corresponds to whatever value that is in our dictionary for the timestamp. And if that value is not the price that the hash map consists of, we know that we can keep popping from the top of the heap. Coding solution here. We are going to initialize a min heap equal to an empty dynamic array. We're going to initialize a max heap to an empty dynamic array, and we are going to initialize this latest variable. We're going to set this to 0. This will just represent the latest price of the stock. This is the only variable we don't need to store in a heap. And then we are going to introduce our hash map with this dictionary variable. Next, for the update, remember we do not need to delete any incorrect values from the maximum heap or the minimum heap, but however, we do need to push whatever the current value is onto both of those heaps with this function. So first, what we're going to do is update the latest, and that will be whatever, if this timestamp is greater than our current latest variable, then we will update. The next thing we're going to need to do is we are going to need to update our timestamp in our hash map. And this function we would do even if this timestamp did not exist in this dictionary. We would still initialize the value the same way. So this works for both updating and inserting into the hash map. And then lastly, we need to just use our heap queue module, and we're going to push onto the heap for the min heap. Pretty straightforward. The one thing is we're going to use an array. You can also use a tuple for this for the same result. And what we're going to do is we're going to actually flip-flop these. Price will come first, timestamp will come second, and the reason for this is because the heap queue module, when given a list, it will sort based on the 0th index of the list. So we need the 0th index of the list to be the minimum price of the stock, or the price of the stock, rather than the timestamp. And we're going to need to do the same thing for the max heap. And the one change we're going to make is we are going to turn this into a max heap, because Python does not support a max heap in the heap queue module. So we can easily turn a min heap into a max heap by just multiplying by -1. And that's our update function. We do not need to delete any incorrect values, which is the main trick of this problem. For this current method, this is the most straightforward out of them all. All we have to do is just return whatever the value is given the latest key. So whatever the latest price, so this returns the latest price of the stock, so whatever the latest timestamp is, we know we can just return that value. And then for the maximum, all we need to do is, so this is very similar to the minimum, and what we need to do is we need to pop from the heap. And first we'll pop from the heap, and this may or may not be the maximum value. So the reason why it might not be the maximum value is the maximum value might have been changed in this update. So we need to compare this to whatever the price of this. We need to compare this to whatever the price of this current timestamp is in the dictionary. And if they're not equal, we know that that's an invalid value. So as we add self.maxHeap, as we pop, we're going to store the price and the timestamp in here, and we're going to initialize a while loop, and we're going to say while the price, and remember this is a max heap, so we're going to have to say times -1, does not equal the current value of the timestamp in the dictionary. So while this price does not equal, we know that we can just keep popping. And the reason this works is because once this ends up being the correct value at the timestamp, we break out of this loop. And once we break out of this loop, we know we have a valid maximum, a maximum value that hasn't been changed. So what we now need to do is we need to add this value back onto the heap. And how we're going to do this is we're going to do it exactly how we did it before. This is max heap. And we're going to add price. And we're going to, we don't need to actually multiply that by -1. because we actually never changed it, and then price, and then TS here. And then we're going to just return whatever the price we have in this variable, but now we have to multiply by -1 to return the correct price. Now for the minimum, it's very similar. We are going to we're going to pop from the heap, this time the min heap, and we're going to have this while loop while price does not equal whatever the current price is in with this time stamp. Whatever the current price is for this timestamp, while they do not equal, you're going to just keep on popping from the heap. And then we're going to need to push whatever value breaks out of this loop. We're going to need to push self dot min heap, and we're going to need to push on the list price timestamp, and we're going to return the price. So that's all the code is. For time complexity, pretty straightforward as well. The most straightforward is this current. All it is constant time. All we're doing is reading from a hash map. So sorry, constant time. And then for this update function, all we're doing here is we are pushing to a min heap and pushing to a max heap. Pushing to a heap is always a log n operation, and you're doing it twice, so 2 times log n. However, big O notation, all this would be is big O of log n, because we drop constants. For the maximum, all it is the same thing in terms of we're popping from the heap and we're pushing to the heap, which are both log n operations. However, this while loop, in the worst case scenario, this while loop could theoretically run n times if the timestamp has been the same for every value in the stream if it's the same. So technically, this one would be big O of n log n. And the same thing would apply to this minimum. So this is all it is. Let's run this and see if it works. Really, the only tricky thing about this is understanding that the update function here, we do not need to update any of the values in the maximum and minimum. We can handle those when those methods are called. And this worked.